we go. Welcome, everyone. Day 3 of Hope. We are standing here for social defense technology, or as it says in your guide, the geeky personal and social impact slides of creating defensive technology. Huh.
We shortened it.
It's good that you shortened it.
Yeah, it's good. The shorter the track, the better.
That's actually 3 lines. That's the longest. Anyway.
Yeah.
Number 97, Mitch Altman, and number 80, Lady Ada.
Hi, I'm Lady Ada, let's press play. I know it's early, but we're gonna show you some really cool stuff today. So I think anyone who got up at 9:30 to come here, it'll be well worth it. You can tell people like, oh my God, this talk was really hardcore. So basically, to introduce ourselves really quickly, this is Mitch Altman. Best known for his fabulous hairdo, as well as inventing the TV Be Gone. You can.
TV Be Gone.
They're sold out. Like he was selling them at the vendor area, and they're gone. Like hotcakes. How many have you sold?
About 200.
No, I mean total.
Oh, total 100,000.
Yeah, so that's like 100,000 people out there turning off TVs. So that's really awesome. It's like $25. It's a really good deal, and so it's like 3 years ago, and he's been doing that for a while. And you can go to his website and read more about the project. I think there's see press and also buy them. And my name is Lamore Lady Ada, and right now I'm an R&D fellow at art gallery in New York City called iBeam, where I basically get paid to do this sort of stuff, which is kind of neat. And I'm going to be talking about cell phone jammers and like how you can build your own, and I'll be getting like really nitty gritty. So hopefully you guys have a little bit of electrical engineering background. If not, I'll try to kind of go a little slow and be detailed about it, because I really just want to get all this information out there, because it's really dangerous. But before, so sorry, this is the slide that just shows you the two projects. So, it's kind of neat. It's just like technology that turns off other technology, and we both have pretty neat little logos, and then pictures of about the scale. And I have this white cell phone jammer here. I can show you later the scale of it, how big it is, about this big. But first I want to talk about some research that I did a couple of years ago that led me to design cell phone jammers. And I figure we'll get really geeky, but first let's talk a little bit about sort of the art history of it. So what's cool about this stuff is that these technologies, they're not like a toaster oven. Like there's a social impact of designing technologies that do things like turn off TVs covertly or shut off cell phones. And the first and foremost is culture jamming. I mean, shutting off a TV is basically like saying no to mass media. And the most famous culture jamming group, I have a demonstration up there, is from the Billboard Liberation Front. And if you live in a major city, hopefully you've seen their work.
Great guys.
Yeah, they're hardcore, and they like to scale things. And so, they take billboards, like this one is, Think Different Apple campaign. They said, it's probably not appropriate to use the Dalai Lama to sell computers. Like if you think about it, that's kind of fucked up. And so, they hacked this sign, and it's probably up for a couple days. So basically, what they're doing is they're taking a billboard that's used to sell stuff, and they're using it to fight, to poke back at the company. It's just basically an inversion. We're just taking what they're doing and turning it against them. A lot of hacking is about this, hacking a website and, like hacking the New York Times and using that to diss Markov or something, a popular example or something like that. So, this is it's a popular way of, and the Guerrilla Girls do this, a lot of art groups do this.
And it gets people to know that you're not alone.
Yeah, it's neat. And so what really started me on this track of designing sort of technologies was this, in 2004, which is about when I had to come up with my thesis proposal. So it's good luck for me. Is this study? It was done at the Lemelson MIT. Lemelson MIT is a business group, and they basically went around and they asked about 2,000, 3,000 people or so, what do you really hate? And the slides are up there, and so basically people hate cell phones and televisions more than they hate ingrown hairs, which is like pretty inspiring. And these are technology. I mean, alarm clocks. Okay, it's not really the alarm clock. It's people don't like getting up. That's a little different in my opinion, but. People don't like cell phones and TVs, and why? Well, what I theorized was that what people don't like is they don't like being bombarded. And the problems with televisions is that like you can't help it. Like you've been in a bar or restaurant and you can't help but like look. You're like trying to talk to somebody and you're like the sports and it's moving and it's bright and so you can't stop looking. And it's like a brainwave problem. Like it's not your fault. It's like the part of your brain that tracks gazelles on the savannah. Like that, it's actually the same part. There's MRI studies, and if you guys are interested, I can give you the reference. You can't help it. You're like, oh, it's a gazelle. No, it's somebody throwing a baseball. So, that's why TV suck. Is like you can't escape them. They're everywhere, and they put them everywhere. And he'll talk about that for sure. And cell phones. It's like, it's not that people are calling in the cell phone. It's that you're on the train from Boston to New York, and this girl is talking for 2 hours about this guy from MySpace she hooked up with, and she's like, "Can you believe it? Can you believe it?" And like then, and then I hooked him up, and then I sent him an no, it's like everyone else was going crazy too, so she deserved it. But it's like it's not like we hate all TVs and cell phones. It's just there's appropriate times for it, and we just want to bring that control back to us. Yeah, that's reasonable. So this is some examples of me using it, and this is awesome cartoon. It's basically you're making a comment. You're saying, I'm tired of technologies like intruding upon me. And it's also like really awesome to like just be like ding, like mute switch.
Yeah, power.
So and people who do computer hacking, this is sort of familiar. I mean, what is a TV be gone? Well, it's actually, if you think about it, it's a little universal remote in a little box. It's just really small and has only the off button. And so it's kind of like spoofing, like you're fooling the TV into thinking that it's a real remote. And as I'll show more technically later, a cell phone jammer is really just a denial of service attack. You're just flooding like the bandwidth with noise, and it just like the cell phone just can't keep up and it just goes, no, sorry, I'm done. And if you want to like really get more in depth into this stuff, there's actually a whole group of artists who do work with technologies that are kind of, well, they're noir. There's something kind of like scary and weird and strange about them. And like this is a quote that from Fiona Raby and Tony Dunn, and they wrote a really good book about this, so read about it. And it's all about like making technologies that are, they're fucked up. They're technologies that fight back. They're technologies that defend you, like stuff like cell phone jammers, things like CDs that are filled with like traffic sounds, so that when people call you up and you want to pretend like you're in traffic and not sleeping in, you can be like, you put on the CD and then you're on the phone and you're like, oh, I'm so sorry, honk, honk, I'm in traffic, honk, honk, I'm trying to get there as fast as I can, but, I don't know, like 93 is backed up, and then you can hang up and go back to sleep. These are technologies that really help you, not like a toaster oven. It doesn't really help you. It doesn't really help you get through your day. So a great example that I like to show is, it's an art project done actually at the MIT Media Lab, called the No Contact Jacket. And this is, I don't know if you can see, the projector isn't really good, but there's this purple high voltage arcing happening on her left shoulder. I don't know if you can see it, but you can go to the website, nocontact.com. And this jacket basically has a switch on it. And if you're female and sometimes you walk around late at night in some kind of scary neighborhoods and you're worried about guys like grabbing you and I don't know. This is a commentary about how it's scary sometimes to walk around alone at night, and I get scared. And so you have this 5,000 volt jacket, and so it's rubber on the inside, and then there's basically a taser sewn into it with wires that go through, like it's conductive. And so if anyone grabs you, there's a video of it on the website. It's like being tased. So it's kind of interesting. It's not that this is sold. You can't buy this, but it's a commentary about fear and armor and clothing and how we protect ourselves. So now we're going to pass the mic off to Mitch, and he's going to talk about the TV be gone and all sorts of cool stuff you can do with it.
Yeah, and then we'll go back to Lady Ada about how to build a cell phone jammer. So, as you know, I invented TV Be Gone, which is a remote control that turns off televisions. So, welcome. We should all play our part, and I'm doing mine. So, TV Be Gone has one button because, in my opinion, and clearly some other people, TV only has one button, which is useful, and that's the off button. So, normally when I give a presentation, and I've given zillions now, I go through all this stuff about media, but you guys are too sophisticated to go through all that. But I do want to just touch on a few things quickly. So, TV exists for one thing and one thing only. Can you guess what it is? Yeah, I heard some people say it's, those are, the main thing is to make money for the TV stations. And they do all sorts of things to do that. And there's nothing wrong with making money in and of itself, but when the purpose is only to make money, there are consequences for it. It's not for my well-being, for your well-being. It's to make money. So one of the things they do is just to get you to sit there, and the worst thing about TV, in my opinion, is that time goes away. And time is one of the few things that is really, really valuable. Because once it goes away, it's gone. You know, we're born, at some point we die. What do we do with that time in between? I mean, we can choose to watch TV, you know, if it's a choice, but if you just sit there, you watch some, let's see what's on. Nope, that wasn't good. Let's see what's on next. That wasn't good. Let's see what's on next. Okay, 3 hours go by. I'm an ex-TV addict. Hi, my name is Mitch. I'm an ex-TV addict. I have been through this, and maybe some of you have too. So, but there are other things about TV as well, I don't know if I really want to go through all of this, but I'm one of the people that helped develop virtual reality back in the day. It was called the 80s, weird time. And one of the things that we discovered is that human brains, take very, very, very little to call something real. All you have to do is show something, repeat it a few times, and your brain goes, yep, that's real. My intellect can be telling me I'm sitting in a chair in Redwood City, California, in an office building, but everything else in my being is saying I am floating through space, looking at clouds and purple pigeons floating by, and there's a folk singer singing a bad folk song. That was one of our virtual reality worlds. And, you know, that's real. So TV makes use of this a great deal. You just put something on there, repeat it a few times, and it's real. And it's putting out there, when you watch the news, scary shit, scary shit, scary shit. And the world starts seeming like it's, you know, kind of a scary place out there.
Well,
And
it is this week a little bit, but
yeah,
but
well,
not here. We're fine. If we had to get a Big Mac or something, you'd be happy. Starbucks. Yeah, don't worry about it.
yeah, just roll over and go back to sleep. So, anyways, you know, the world is actually an amazing place. It's scary and it's wonderful and it's weird and it's kind of all these things in between. But TV just kind of repeats certain messages. So, anyways, just one other thing I want to touch on, just personal experience. As a little kid, I was really very, very unhappy and actually really depressed. And, you know, maybe some of you can relate to this too. I'm a geek, and I was beaten up for being a geek, being weird, being, you know, being gay, and, you know, can't pass. And when I'd come home, my parents didn't really understand, so I would just retreat and watch TV. And by doing that, I didn't really learn how to deal with people. I was just like more and more introverted as time goes by, and so people would pick on me even more, and I'd come home and just retreat into TV even more. So I'd watch TV, and I'd even be thinking as a little kid, you know, this Gilligan's Island episode is really stupid. I don't like it. Why am I watching it? But I didn't really think about it much further than that, and I kept watching it. So I have this thing about TV at this point. It was actually around 1980. Nothing really happened. Just something clicked in me, and it was like, you know what? I don't have to watch this shit. And since then, I've been able to have a lot more time, a lot more energy, and my outlook on the world certainly has improved. I would not have had time to build this if I watched TV. So one thing, the Hope Guide even touched on this quite powerfully, I think. They said, you know, in the conference, there's so many cool things to do here. There's no way you're going to be able to do it all. There's no way. So just go in there and do what you can. And really, that's life. There's way too many cool things to do out in our world, in our lives. Why waste any moment of it doing something you don't really, really enjoy doing? You know, there's just way too many cool things. So, go on, yeah. So, this is the problem that I've been seeing for a long time. TVs are popping up everywhere. We can't rest our eyes often enough without being marketed to. They're popping up all over in public places. You know, it's if you choose to watch it at home, whatever. But in a public place, we don't have the choice of it being there. We don't have the choice of the programming. We don't have the choice of it being on or off. So. Okay, so so that brings me to being an inventor. I didn't really have the courage to call myself an inventor until I started really working on TV Beyond. But I've been an inventor all my life, and the inventing, as I see it, has these three steps. So there's a problem, and the problem is TVs in public places. And I came up with an idea to solve this problem. I was sitting in a restaurant with some friends I hadn't seen in many years, and we picked a restaurant that was kind of centralized in the huge Bay Area, and it happened to have a TV on in the corner. And we were talking to each other, but we kept getting distracted by this thing that demanded our attention, and we couldn't help ourselves. I couldn't help myself. So we just started talking about it, because what else could we do? And wouldn't it be cool if we could just turn off things like that anywhere we go? And of course I realized I could, because I'm a geek. And we even named it right then and there. And that was actually 13 years ago. And given the nature of life and working in electronics, the last thing I wanted to do was come home and play in electronics. But after about 10 years and telling all my friends, and them telling all their friends, and them telling all their friends, you have to build this thing. I really need one. And so I finally did it. Started about 3 years ago. It took about a year of my life. Conceptually, it's just so easy. You know, a little microcontroller, timing, pulsing infrared light, just sending out the off codes. But it took me a year to get these codes together. And maybe I'll go into that a little bit. But implementation is TV Begone, and here's the schematic for it.
This is small.
Yeah, can't really see it. Maybe go to the next one. Is the picture of it?
No.
Oh, you didn't put that in there.
There's it, yeah.
I don't know. How many people want me to go through like the more geeky, like how this works?
No, you just do it. Yeah, we have time. Do it.
Okay, so
quickly.
I'll just do it kind of quickly. Over here.
Why don't you grab the mic? You can take it with you.
Oh yeah. So sorry about that. The microcontroller is really the heart. This is, as you can see, really simple. There aren't many parts. It's mostly just a microcontroller that has some timers that make pulsing infrared light very simple. This is a chip that's designed specifically for infrared remote controllers. So it has a few instructions. It's made by Zilog. The old timers might remember a Z80, one of the early microcontrollers. This is a spiffed up version of that that's very small, and it has an expanded instruction set, and it has timers built into it to make remote control timing simple. And so I have my firmware and a database of all the codes that took me a year to compile. And the way I got the codes was taking universal remote controls, and I built a system to acquire the data from them. I started a company in Silicon Valley, I mean, and it made RAID controllers, which is something that just makes disk drives look cool to a computer. And I wrote the firmware for it, and I had a bunch of prototypes. So I could have bought a digital scope or some kind of professional data acquisition system, but those were like $10,000 3 years ago. But I had these prototypes lying around. I just hacked into that and wrote the firmware, since I had control over it, for this three-ware RAID controller, and it turned into a TV Begone data acquisition system. And it works really well. It's tedious, though. I'd punch in the first code for my universal remote control, start up my software, press power, and repeat that about 50,000 times over the period of a year, and analyze the data. And if anyone's interested, corner me later. I can go through that process. But so anyways, that turned into a database for TV Begone. And when you press the button, which is
Bottom
where's
left.
the button? Bottom left.
Yeah.
Yeah. And the microcontroller sees that, and it just sequences through all of the off codes. One of the things I had to do is, what's that?
Oh,
Yes,
yeah.
it really needs a crystal because the timing has to be plus or minus maybe 5%. When you send out an infrared set of pulses, the TV receiver receives that. If it's not timed properly, the TV is going to ignore it. So I use actually a ceramic resonator, which is cheaper. And so one other thing I experimented with is the time between each code. I made it as short as possible because there's so many codes. There's thousands and thousands and thousands of brands of TVs, and I narrowed it down to 117 codes, which will turn off like 99% of them. And that was part of that year-long chunk of my life, so that we could turn off TVs in public places. And what else can I say? The power supply is something I worked a lot on too, and according to the math anyways, I wanted to have 6 volts go through the infrared emitter, which is over here, and really pump it out so it could get a TV across a crowded room and off in the corner, and so you don't have to aim at it too well. And I wanted to use an infrared emitter that would have a wide beam, but not so wide that it disperses all the energy and it can't be too far. These are some kind of the engineering trade-offs. But it turns out that a 3-volt fatter battery works better, and in my next version of TV Gone it'll have that. But if you have a TV Gone and the battery runs out, use 2 fat batteries rather than 2 thin batteries and a fat battery. And that's on my website, tvgone.com. I think it's probably enough about that. Did I miss anything? Yeah, question? Yeah, I'll repeat the question. All the different brands, how did I come up with 117 codes? A lot of field testing. This is what Best Buy is really great for. So Best Buy is actually particularly good because they set it up so that as you walk in, you're confronted with a wall of TVs. And so it's a just direct shot, you know. They all turn off. It's kind of amazing. I have a little video in here I'll show momentarily. I am not. Actually, in Best Buy, another reason it's really good is because people there got paid minimum wage and they just don't care. And they leave me alone. Other places I would go in and I'd talk to the manager and I'd have to tell them, and they're AV geeks from high school just like me, so they kind of understand, but it's like, no, dude, you don't understand. You have to program it in order to turn off a TV. And it's like, no, I'm inventing it. That's why I'm asking you about this. I said, dude, it won't work. And I just point at a TV, it turns off. And then, of course, he calls all the other people over, and he says, hey, this guy made this thing. And so anyway, that's cool. But Best Buy is the best because they have zillions of TVs, and they just don't care. So once I got it all together, I knew I wanted to make one for me. But since I told my friends, and they told their friends, and they told their friends, it's like, I should make a lot of these things. And I just at that time, Freeware, the company I started back in Silly Valley, they sold the company for some ungodly amount, and I was diluted down to almost nothing. But I had they sold it for $150 million, and almost nothing percentage of $150 million was enough to buy 20,000 TV Begons. So perfect timing. I made 20,000 TV Begons, and I figured this is an opportunity to get a message out there, which is, you know, my subversive mind at work. I have an agenda. Turning a TV on or off is a choice, not only in public places, but at home. I'm a big fan of conscious choice, and I'd like to give other people an opportunity to think about it and, you know, make that conscious choice for themselves. So.
Want to play the video, or?
Yeah.
Video. Hopefully the AV will work. Nope, no sound. Can we get the sound on the video? Sorry, well.
The sound is important.
Is it working, Martha? It absolutely is. Yeah, we tested it beforehand, so.
Yeah, if we turn up
Just let me know
Oh yeah, we're not.
Nope, I got it. No, I didn't. It was an instant.
Are you sure he's been sick?
There you go. Shit, I got a wall. Yo, go, yay!
It's sort of like no evidence, right?
That was an experience of someone using a TV or a TV Be Gone in public for the first time.
A positive experience.
Yeah. So one of the reasons I knew that this was a hit, besides for the first day of sales on Wired.com, determined the first day of sales, and I had to get the website going with my friend Chris, who's in the audience. We were up all night, and we had to get it up before a Wired.com article was going to be published online. It's like, yeah, we need some padding on Tuesday. We'll put it up there. And I figured, Wired.com? Who's ever heard of Wired.com? But maybe a few people will come by my website. So at 5 in the morning, we finish, and the email indicator goes ding, saying, hey, you got an order. And I was like, something going wrong? And then ding, ding, ding. It's like, what is going on here? So I guess people do pay attention to Wired.com, including All Things Considered on NPR. And at 9 in the morning, after no sleep for who knows how long, I have to do an interview live for national radio. And I guess I did okay because the AP called a few minutes later, and then the New York Times, and then Dan Rather, People fucking Magazine. The next day, Fox calls. Fox.
It's like if there's one thing they like to hear about themselves. So it's sort of like, it's like, wow, it's like bad attention is still good attention for the media.
Yeah, the media is very narcissistic.
Yeah,
So
they don't
any
care.
opportunity to talk about themselves, they
Yeah.
had the perfect opportunity here. What I found, though, is that people who work for TV, who make TV, love TV Be Gone. They come home, the last thing they want to do is turn on a TV. They don't have enough time. They do something they enjoy. Making it, not watching it. So, but one of the reasons I knew that I was really doing something cool was that people started hacking my hack. So if you go on Google, there's like sometimes up to 1 million hits for this thing. 2 years ago, there were 4. Those were my 4 different domain names. Someone put it inside of a cell phone so they could be more stealth about it, a gutted cell phone. A French fan, I have a lot of fans. I mean, it's weird to have fans. It's kind of nice, but it's weird. He put it inside of a Galois package. I don't know if you can see from the picture, but there's a little hole in the O. He even went so far as to cut off the filters of the cigarettes, put the TV Be Gone in there, and then put the filters in. I don't know what'll happen if someone wants a cigarette. But Engadget, some weirdo in the audience did that one. And he put it in binoculars to make it go very long distance. Some other weirdo in the audience who works for Make Magazine had some folks there put it in a hat. So then there's this one here that's high-powered, a huge array of infrared emitters with a big battery. The hat's kind of cool because it's just always on, and the infrared emitters are in the visor. And wherever you look, TVs turn off. And Lady Ada did a really cool project for her thesis, which is glasses that you can see through normally, but if you look at a TV, they go black.
Yeah. It's part of a therapy system for people who are addicted to television, so just kind of keeps you down. It's like I made one, and my advisor has it. Like it was part of the deal. Like you get a thesis, I keep the project. Oh, okay. So I don't have it with me.
But it's such a cool concept.
Yeah, but so like the 12, the 3x4, the 12 IR array one with the 9 volt. Like we went to the Blarney Rock yesterday. It's like Hiroshima. It's like the nuclear option for TV Be Gone. It just it's like all black. And I'm like, oh my god, it's intense. Like it's like everything goes out. It's nice, you know. It's like you don't have to go point, you know. It's like all at once.
But it would make you want to not look at the TV.
Yeah, no, it works really well. It's like, oh, well, I don't want to look at TV anymore. I just want to hide because I'm embarrassed. Here's the other.
TV Be Gone, upon your knees. TV Be Gone, turns up the TV. TV Be Gone, listen in your place.
fun for the whole family. Yes.
I have a lot of,
It's a passive-aggressive family.
at least they interact.
Yeah, it's true.
My family didn't, but yeah. So this project was definitely the work of a lot of friends. You know, I had the idea, but I had a lot of friends who helped with this. Not only Chris who helped with the website, but friends who helped with an industrial designer who helped with the weird little Batman-y like design, and my friend Nina who did the graphics, and different friends who did that video. So it's just getting people together. We're all doing what we loved, and when you do what you love and put it out in the world, a lot of energy from that we had goes with it, and other people pick up on it. And if it's a cool idea, it really can make an impact. And one of the things that's really just I'm just amazed with, we all have a lot more power than we believe we have. It's just me, one guy. I'm somewhat intelligent and creative, but I'm no more different than any of you guys. And look what happened just from an idea. And
You can make your sociopathic dreams come true.
it's true, and if I can go from
I'm
being
proof.
we're all proof, really.
Yeah, okay.
And if I can go from being a totally depressed blob as a kid to being someone who does what they love, I mean, I'm making enough money to live off this, and so are all my friends who are helping. We did this not for money, but it turned out to we sold 100,000 of these things, and so I can pay my friends for all their time now. If I can go through all that to do what I love and be happy, anyone can, seriously. So that's pretty much the TV Gone story.
That was inspiring. We're doing questions later afterwards, and people can come up and play with the cell phone stuff and the TV Gone and the hacks. So I'm going to talk about cell phone jamming. My God.
What kind of jerk would
Like,
call?
who would call in the middle of my talk? Good. So you're.
Oh.
Is it on? There you go. Ah, missed call. Oh man, bummer. So, why would you want a cell phone jammer? Well, it's really appropriate in a lot of situations. Not all situations, and a lot of people say like, oh, what if there's a doctor on call or there's an emergency? And it's like, well, I mean, you can be careful about it, but there's definitely times when you want to use it. I want to preface this by like, please don't be really stupid with this technology. Like you can can make this into a 1-watt transmitter that takes out a whole block, but it is illegal. FCC regulation 15.3c makes it illegal to like own, use, operate, sell, etc. a cell phone jammer. It's actually not illegal to talk about them or to tell you how to build one. So,
right, and we're not proposing that anyone break the law.
I don't think I'll be led away in handcuffs in the next few minutes, but that'd be kind of interesting. So basically, I'm going to go through a lot of technical stuff with the cell phone jammer, just because I did sort of the social theory stuff already. But it's really simple. I mean, cell phones, people who've had dual band or tri-band phones, that there's basically 3 bandwidths that a cell phone talks on the RF. It's 800 to 900 approximately, which is the lower band GSM, and then there's 1800 to 1900, 1.8 to 1.9 gigahertz, which is, I think that's also GSM, and then there's like 1.9 to 2 gigahertz or so. I mean, I'm off by a little bit, so you can look this up in the FCC, but those are basically the 2 bands you want to grab. And then, recently I've actually started to get into Wi-Fi jamming. Like, at first I was like, why would you want a Wi-Fi jam? But like, if you've ever gone to the Apple store with a Wi-Fi jammer, it's like really fun. Or you go to a cafe. Like, actually, it makes a lot of sense because, for example, if you live in San Francisco, you know that now Google and the mayor are like interested in making the whole place like Wi-Fi-able, and that sounds like a really neat idea. Like, oh, I can check my email everywhere, but like you want to go to a cafe and you just want to like have a coffee and hang out with friends and not be surrounded by bloggers or like people writing their novels, and they sit there and they don't buy anything, and they're like, well, I deserve to sit here, and a lot of cafes actually. I mean, there's an article in the New York Times about how a lot of cafes, this is a problem for them because they're losing customers because. Like this laptop takes up like 4 people space. It's huge. So these are some reasons why you might want to use a cell phone jammer. And I also want to mention that I'm not an RF engineer, so like I don't really know what I'm talking about, but I know enough to be dangerous. So there's people in the audience here who ham radio geeks who know way more than I do. Like I'm pretty much like, oh, quarter wave. Okay, I put like divide by like light speed, and okay, that's it. That's all I know how to do. But there's really good books out there, and if you read ARL books, they have lots of information. So you could actually be educated about this, but it's like the one class I didn't take in college because I didn't want to. It was hard. So you basically, how do you make a cell phone jammer? It's really, this way is really simple. You can do it more intelligently, but you're just going to take a voltage-controlled oscillator, which I'll refer to as a VCO. That's, standard acronym. And basically, it's a little metal box, and you put a control, like you power it, and you put a control voltage in. And for example, let's say we have a 1 to 2 gigahertz VCO. If you put 0 volts in, it outputs 1 gigahertz. If you put 5 volts in, it gives you 2 gigahertz. And if you put 2.5 volts in, it gives you like 1.5. So it's basically like, it's, the voltage to frequency conversion. It's pretty straightforward. And then you want to give it a sawtooth wave, right? So it goes up, and then, it just sweeps through frequency bands. And then you put that in, and then you make sure that you have the sawtooth wave aligned so that it lines up with the frequencies you want to jam, and then you get this RF sweep coming out, and I'll show you on a spectrum analyzer what that looks like. And then you just put the gain stage is really important. Like that should be really big because you just want it to be really powerful, because you just have to like be more powerful than the cell tower. That's pretty much it. It's not complicated. You can put some noise in there to try to like, spice it up, but I haven't found that that's actually very effective. And so the easiest way to do this is open loop control, and anyone here who's done some engineering knows that this kind of sucks, but it's really cheap and easy. And basically, you get your VCO, you get your gain stage, your antenna, and then you have a tuning circuit that makes a sawtooth, and then you get in there with a potentiometer, and you kind of tweak it by hand, and hopefully you have a spectrum analyzer, and you kind of, it got lined up, good, you're done, and then you close the box, and you epoxy it, and you're finished. So the great thing about this is it's dirt cheap. It's really easy. The problem is that you need a $4,000 spectrum analyzer. So this is like, thank God they're $4,000 or everyone would have a cell phone jammer, because that's like the one thing keeping people from building them. So the VCO is like the interesting part, because it's like, depending on what VCO you get different strengths, different powers, different frequencies. So here are some VCOs, and it's a quarter, so it gives you a sense of the scale. So there's the ones that plug in, and you see the one that looks like an ant. And then there's the little square ones, so those are high frequency. Usually the smaller they are, the higher the frequency. And then the one to the left is hand-built. I usually buy mine from Mini Circuits, so go to minicircuits.com. It's great. You can buy any VCO, any frequency, up to 3 gigahertz. So that's kind of nice. You can build them by hand, and there's information online how to do this. Since the VCO is actually, in a sense, the hardest part to get, it's nice that you can build them by hand. I wasn't incredibly successful with this. I could get it up to 1.5 gigahertz, but not much higher. So you can see that there's 3 plugs. The big silver plug is where the antenna is. The right plug is the power, and the left plug is the tuning voltage. But like I said, it's easier if you just buy the VCO. So Mini Circuits is where I like to go. There's also Micronetics. There's tons of places online. Even Geeky, if you do electronics, you probably have a Geeky catalog. The latest one includes VCOs from Serenza. It's new, so check that out. They're kind of okay. I ordered some a couple days ago. Come in, I'll see how they work. So you can't see that, and I knew you wouldn't see that. So I tried to zoom in to the interesting stuff. So for example, let's say we want to jam Wi-Fi. Well, Wi-Fi is like 2.4 to 2.5 gigahertz. So we go down the list, and we're like, la 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 la. Oh, there's 2 or 3 good options. At the very bottom, there's the Ross 2500. Goes from 1.6 gigahertz to 2.5 gigahertz. Requires 2 volts, takes 25 milliamps, and the power output is 6.5 dBm. If you want to convert that to milliwatts, you do the divide by 10 and then do log 10 conversion. I can't do it in my head. Someone with a calculator can figure it out for me. And that tells you the tuning voltage also. So for example, the 2500 is 0.5 to 14 volts. So there's a graph that comes with the data sheet. 0.5 volts is going to be at the lowest end, and 14 is going to be at the highest. And so you go through and you can mix and match. And you're like, oh, I want to do cell phones. Well, you want to do 18 to 1900 band. Well, you can use the Ross 2000, and you want to use the PCS band 800 or so. You maybe want the 14. It's like you go through and you find out what frequency you want to jam, and then you just pick the VCO. It's that simple. So here's a schematic of open loop control. And wow, it's kind of nose to zoom in. It's kind of nice. So on the left side, you can kind of see triangle waves. That's a triangle wave. That's the tuning maker, the voltage that goes up and down. And then there's a diode noise generator. I didn't find that very useful, but it's just a little, like it takes the noise from a diode. Diodes are really noisy, and then amplifies it. And you sum it together, and then you see the big thing that says VCO, and then you see the thing on the right that says gain stage. That's it. It's like really simple, and that's what it looks like when you build it. And so I have that up here if you want to look at it. The big square thing that says micronetics, that's the VCO. And then the little blue thing is an antenna. And then all the messy circuit stuff, that's the tuning circuitry. And the blue square in the middle is the potentiometer. So you twist that to change what frequencies you want to jam. I'll show this stuff later, I think. Yeah, I'll just go through. So then you turn on your really expensive spectrum analyzer that you borrowed from a friend. This one was actually $20,000, which is why it's in color. And you just look at it, and you can see at the bottom it says, 1.8 gigahertz to 2.1. So you get that nice monolith right around 1.8 to 1.9, and that's your GSM phone, so it doesn't work anymore. So then, you want to upgrade, let's say you don't have a spectrum analyzer, or you want to go, if you don't have a spectrum analyzer, or you want to, do some more dynamic stuff, you add a feedback loop. So the PLL there stands for phase lock loop. And that's basically a device that takes a high frequency signal, compares it to a lower frequency, does some crazy math stuff, and then tells you whether you're on the frequency you want. So this is like the upgraded version. So this is the one that I just finished, and it's got feedback. So the nice thing about this is you can build it, and you don't need a 5,000 spectrum analyzer. It just works when you build it because it tunes itself. And then I just want to zoom in on a couple little things. So there's, I'll zoom in a little bit more. So there's a 555. Thanks, Force Mims, for teaching me how to use 555s to make sawtooth waves. This is the part that makes the 20 to 40 kilohertz sawtooth. And there's some potentiometers. This one, for example, adjusts the bandwidth, what the frequency range is. And then that's actually a digitally controlled potentiometer. So on the fly, you can press a button and change whether you want to jam Wi-Fi or you want to jam cell phones. And then that goes into the two VCOs. I use two VCOs because I want to jam both pieces, both the 800 band and the 1900 band. And then you've got your gain stage and the antenna. It's the same thing, pretty much. Only difference is now we have, zoom out. Man, I'm not doing so well here. Sorry. Aha, there you go. There you go. PLL for VCO tuning. So this little device is nice, dual VCO PLL feedback loop, and it's digitally controlled by a microcontroller. It just tells it, hey, I want to be jamming 1.9 gigahertz, and it just puts it right there, and you're done. That's kind of nice.
And all this is going to be on.
Oh yes, this is all going to be on my website. So this is going too fast, but you can go peruse at your leisure. So I'm going to be showing that stuff up here also if you want to come up and look at it. But basically, what have we said? Well, it's kind of like the stuff I said in the beginning, it's tying it together. Just as we use iPods to block out the world while we're on the train, TV begons and cell phone jammers, they're basically like us saying, we're packed too close and we need some space. We need space for our eyes, we need space for our ears from annoying cell phone conversations. So design technologies to help us reclaim that space. It's really powerful. And I think it's really necessary, especially at places like urban cities and trains and bars and other places where we're packed way too tight.
Yeah, there's so many of us, and we have to learn to live with each other. And these new technologies come out, and the etiquette to go along with them develops rather slowly, much slower than the technologies develop. So we can help that process, us here in this room.
Great. So we have some time for people to come up and ask questions. And then afterward, also you can come up here and maybe I'll show some stuff on the overhead if people want to see that.
The rear microphone. The red light's on.
Not yet.
Yeah, the front mic works.
Hello, hello. This one
There we
works,
go.
okay. All right, you go to a supermarket, and you're in the checkout stand. There's these annoying TVs that just sit there and spew out that crap for your ears. Does your little TV Be Gone work on those?
Yes.
Wonderful.
Wow, that was a good question.
Yeah, they're all over the place. I've never been to a Walmart, but I have a lot of fans who've emailed me and said they're very effective in Walmarts, the TVs that advertise there.
I have a question on the cell phone jamming. How did it work out with the spread spectrum phone, since that was a technology designed for it to be jam resistant?
Yeah, I don't know. That was really weird because I read a lot of theory, like I read a lot of papers about this before I built it, but it works anyways. I mean, it doesn't matter. Like that, you remember that monolith? Like 1.8 to 1.9 was gone. Like it was all like noise. I mean, if you're jamming all the spread spectrum, then it doesn't matter, I guess.
Yeah, okay. But the other thing is, did you ever play around with maybe using some of the chip code sequences that the CDMA phones use? But that could, I mean, that way it would be more correlated.
Yeah, a lot of people have been mentioning that, and I think that's a really good idea because you can like really reduce your power. Like I said, this is a denial of service attack. It's the most brainless, like brute force way of doing it. But yeah, GSM codes, like you could do this a lot easier with just a little bit more intelligence. I just don't have that intelligence.
Okay, and finally, the thing on the TV Be Gone, did you ever play around with using any of the PICs, the PIC processors, or you went right to that Xilinx?
I went right to the Zilog.
The Zilog, yeah.
Really, the main reason I chose Zilog is because I had a development system already.
I see.
And it's also pretty cheap. The chips I developed it on one-time programmable chips, and they're $5 a piece if you buy one, more than a PIC processor. But the development environment was $35, but they gave it to me for free because they like me. With all these places, all you have to do is say, hey, I'm developing something, I might sell 1 million chips, and they go, okay, we'll give you a development environment. And you don't have to be telling the truth.
Well, I'll just have to reprogram my PICs to go from the General Instruments code to the cell phone codes. Anyway, thanks.
Yeah.
So have you found that the TV Be Gone turns off other things like DVD players or stereo systems or anything like that? And if so, what?
Right. Well, manufacturers, one of the difficult things with why it took me a year is there are so many different ways that manufacturers do their infrared remote controls. But it would be an amazing fluke if one manufacturer who isn't talking to another manufacturer had a same code for anything as another manufacturer. As it turns out, though, I have 2 emails from people who bought TV Be Gone saying that it turned off their VCR. So there's at least one VCR out there that will turn off with one of the TV off codes that's in TV Be Gone. So it's probably made by the same manufacturer. Yeah.
But you have to use
Oh,
the mic.
microphones,
You
yeah.
can't just raise your hand.
Yeah, I was just going to comment on the probably reason why it worked.
You just,
A lot of the
rough.
a lot of the manufacturers, they buy a chip from Signetics or any number of the chip manufacturers, or Sony makes them. If you're, why go the tooling or the design of making an IR chip for each different type of product? Just use the same chip in all their product line, because that's probably why the off codes. That's why you're lucky you only had to do some 100-odd off codes instead of 1,000 off codes.
Yeah, there's thousands and thousands of different TVs out there, and there are some sort of standardized ways of doing it, but even within those standardized ways, there's so many variations of the way they've put it together to distinguish. We got to stop now.
Yeah.
So, Thanks, everybody.
Sorry.